So we're given that a is a positive real number, and we're also given this for free. So this is an assumption. What we're trying to show is this. So all we have to work with is pretty much this piece right here, and that is the goal. Now think about the number x. What can x be? X can either be greater than or equal to 0, or it can be negative. So let's begin this problem kind of like we did the other problem by looking at cases. So let's assume that x is greater than or equal to 0, which would mean that the absolute value of x equals x. Now, remember the one fact that we're given. We're given that this is true. So we know that this is true. That's given to us for free. Now, because we just established this equality, we can use substitution, and so that this, which is that, can turn into that. So here we are. This is what we have just established, and notice that this is like half of the goal. Now let's look at the other case, and hopefully we can create the other half of the goal. So we did the case where x is greater than or equal to 0. Now let's consider the other case where x is less than 0. Where, of course, if x is less than 0, then that means that the absolute value of x equals this here. And so now if we look again at the same piece of information that was given to us, now by substitution, that, which is that, can turn into that. And if we look at property number 16, so look at your cheat sheet, property number 16, if we apply it to this right here, here is what we would get. Yeah, so by property 16, we go from here to here. And this is good because this is the other half of what we're trying to show. And we're done because if we take this and if we take that and if we combine them into one inequality, boom, that's what we get.